Welcome to This Explainer. I am so thrilled you're joining me today because, frankly, we are going to explore a massive paradigm shift that is happening right under our feet. For generations, we've looked at wastewater as a hazard, right? It's dirty, it's dangerous, and it's something we just need to get rid of as quickly as humanly possible. But today, we are going to flip that idea completely upside down. We're going to look at how modern science and engineering are transforming wastewater from a dangerous liability into an incredibly valuable resource. We are talking about a literal journey from waste to absolute wealth. Let's get into it.
But before we get to the really cool solutions, I want to hit you with a staggering fact just to set the stakes here. Globally, right now, 80% of wastewater is not collected or treated appropriately. Just let that sink in for a second. 8 out of every 10 drops of water we use and pollute just flows straight back out into our environment. And with forecasts showing that almost 70% of people will soon be living in urban areas, the pressure on our water systems is just skyrocketing.
Okay, let's dive into this a bit more. Consider the breakdown of our planet's water. We live on a blue planet, right? There are oceans everywhere, but 97% of it is salt water. And of that tiny sliver of fresh water, most of it is completely locked up in ice caps, glaciers, or deep underground. When you do the math, ultimately only 1% of the world's water is accessible surface fresh water. Just 1% to sustain all of human agriculture, industry, and our daily lives. When you realize that, our current wastefulness isn't just kind of inefficient, it's genuinely terrifying.
So, here is our roadmap for today. We'll be covering the global crisis, the flawed linear model, a circular water framework, rethinking how we collect water, the technologies powering this shift, and finally, resource recovery factories.
All right, part 1, the global crisis and why we have to adapt our water strategies immediately. The stakes of our current water stress are incredibly high. Over the past 50 years, water-related hazards have completely dominated the list of global disasters. We are talking about severe droughts, storms, floods, and extreme temperatures claiming well over 1.2 million lives. To put the financial toll into perspective, in Europe alone, floods and storms caused a staggering $377.5 billion in economic losses. So this isn't some distant future threat. This is an immediate, grim reality that absolutely demands we completely reshape how we manage our water to build resilience.
Moving on to part 2, the flawed linear model.
You know, a massive part of our vulnerability actually comes from our aging infrastructure. Most of the dams and sewer networks we rely on today were built way back between the 1930s and the 1970s, and they were built for a linear economy. The traditional mindset was literally take, make, use, and discharge. You extract water, you use it, and you dump it. Compare that absurdity with the circular mindset we desperately need right now. Reduce, reuse, recycle, and recover. And this brilliantly illustrates exactly what we're doing wrong. In the old linear approach, we take pristine fresh water, pump it to a plant, distribute it for domestic, industrial, or agricultural use, and then, after using it just once, we discharge it right back into the environment, often without adequate treatment. With global water demand expected to exceed our supply capacity by 40% by 2030, using this precious resource just a single time is a luxury we simply can't afford anymore.
So what's the fix? That brings us to part 3, a circular water framework.
To actually solve this, we have to design utilities that cut out waste entirely. In a systemic circular economy, there is no end of the line. Instead of a straight pipe ending in pollution, we create a continuous loop. We combine hybrid green infrastructure with digital smart sensors to optimize absolutely every drop across urban, rural, and industrial settings.
Part 4, rethinking collection. Let's talk about how we actually implement this on the ground.
So the crucial point here is that bigger isn't always better. Pumping water miles and miles away to a massive centralized plant just to pump it all the way back is incredibly inefficient. Instead, we're seeing a total revolution in decentralized sanitation right inside our buildings. Take the Run for Life project operating in Spain and Sweden, for example. They use this amazing 3-pipe home architecture. By collecting blackwater, greywater, and organic kitchen waste in completely separate pipes, and using ultra-efficient vacuum toilets, they treat the waste right on site. This kind of localized control turns an everyday office building or an apartment block into its own self-contained hybrid network for reclaimed water. It's a real game changer.
Which brings us to part 5, the technologies powering the shift. Let's look at the fascinating plumbing that actually cleans our water.
How do we actually clean the water so it can be reused? Well, it generally happens in 3 main steps. First up is primary treatment.
which is highly physical. We're screening out large chunks and letting heavy particles settle out using just gravity. Next comes secondary treatment, where things get biological. Here we use hungry, microscopic bacteria to digest the biodegradable organic matter. Finally, we have tertiary treatment. This uses advanced filtration and chemical or UV disinfection to really polish the water until it's perfectly safe for use. Let's look a bit closer at that secondary biological step, because this is where it gets really interesting. We have two main approaches, aerobic and anaerobic. Aerobic digestion uses oxygen. It works great, sure, but pumping all that air into the water consumes a massive amount of energy. In fact, traditional wastewater treatment plants use between 1 and 3% of the entire global energy output. On the flip side, we have anaerobic digestion. These little microorganisms work without oxygen. They are incredibly efficient, they produce far less sludge, and honestly, the best part, as they eat our waste, they essentially burp out biogas, pure methane, which can be captured and used as a renewable energy source.
Now, when we want to get the water incredibly clean, say for advanced agricultural reuse or highly sensitive industrial processes, we have to use membrane filtration. To grasp how this works, you need to understand osmotic pressure. Basically, it's the minimum pressure required to stop water from naturally flowing across a semi-permeable membrane. In advanced treatments like reverse osmosis, we use high-pressure pumps to force water through incredibly tight membranes. We are literally overcoming this natural osmotic pressure to separate pure water from salts, bacteria, and viruses.
Now, what's really interesting about this is how precise we can get. Depending on the pore size of the membrane, we can step down from microfiltration to ultra and nanofiltration, all the way down to reverse osmosis. As we crank up the pressure and shrink those pores, we aren't just catching algae and bacteria anymore. We start filtering out microscopic threats like viruses, aqueous salts, and dissolved organic compounds. It's essentially microscopic plumbing, ensuring the water is perfectly tailored for its next life.
And finally, Part 6, Resource Recovery Factories. This is where all comes together. Treatment plants, whether they are massive city facilities or those localized three-pipe building reactors we talked about earlier, are no longer just disposal sites. They are actual wealth extractors. That anaerobic digestion we discussed gives us biogas for heat and electricity. We can recover valuable nutrients like phosphorus and nitrogen, which prevents toxic algae blooms in our rivers and turns those nutrients into potent NPK agricultural fertilizers. And of course, we recover perfectly reclaimed water, ready to be safely used as flush water or for crop irrigation. That preserves our precious 1% of available surface fresh water.
So we have completely shifted the paradigm. Wastewater isn't waste anymore. It's energy, it's fertilizer, and it is absolutely our most critical resource ready to be used again and again. So I want to leave you with a provocative thought to end our explainer today. Knowing this hidden wealth, and knowing the incredible technologies we now have capable of extracting it, what are you actually sending down your drain? Thank you so much for joining me today, and I really hope this completely changes your daily relationship with water. See you next time.